Have you ever pondered what shape the universe might be? This question may seem simple at first glance, but don't be fooled. The shape of the universe is an infinite enigma that has been fascinating scientists, philosophers, and thinkers for centuries. It's not just about the physical form it takes, but also about the profound implications it has for the ultimate fate of the universe and the nature of space-time itself. Imagine the universe as a massive cosmic donut, or perhaps a never-ending flat plane, or even a complex, multi-dimensional web. The mind-boggling possibilities are as infinite as the universe itself. Each shape suggests a different story of the universe, its birth, its life, and its eventual fate. The shape of the universe is intrinsically linked to its destiny. If it's curved like a sphere, it could collapse back onto itself in a big crunch, undoing the Big Bang. If it's flat, it might expand forever, growing colder and darker until the last stars fade away. And if it's saddle-shaped, it could stretch out into infinity, getting sparser and emptier with time. But it's not just about the future. The shape of the universe also tells us something about the nature of space and time. Is space something that exists independently, a stage on which the cosmic drama unfolds? Or is it something more dynamic, intertwined with matter and energy, bending and warping under their influence? These are not just idle musings. They are fundamental questions about the nature of reality itself, and they are questions that science is striving to answer, using cutting-edge technology and ingenious theoretical models. So, are you ready for a cosmic journey? A journey that will take us from the familiar three dimensions of our everyday experience to the furthest reaches of theoretical physics. A journey that will challenge our preconceptions and stretch our imaginations to the limit. Let's dive into 10 fascinating theories about the shape of the universe. First off, we have the flat universe theory. Picture a two-dimensional plane extending infinitely in all directions. That's the basic premise of this theory. It suggests that our universe, rather than being spherical or curved, is flat and boundless. Now you might be wondering, how can we even propose such a theory? It all comes down to data from the cosmic microwave background, or CMB. This radiation is a relic from the Big Bang, and it's spread across the entire universe. By studying the CMB, scientists have found patterns that suggest a flat geometry. But here's where it gets interesting. If the universe is indeed flat, then it must also be infinite. This means there's no edge, no boundary. It just goes on and on. So imagine that. We might be living in a never-ending cosmic plane. The universe in this view is not a finite sphere, but an infinite plane. Every direction you look, every star you see, could be part of an endless cosmic expanse. So, we might be living in a never-ending cosmic plane. Next, we explore the closed universe theory. This intriguing concept suggests that our universe is not limitless, but rather finite, taking the shape of a colossal sphere. A fascinating aspect of a closed universe is its impact on the trajectory of light. Instead of a straight line, light in this universe would curve, tracing out a circular path around the universe. Think about it like this. If we could somehow shine a beam of light in one direction, it wouldn't just disappear into the infinite void. Instead, given enough time, it would loop around and come back to us. This mind-bending idea is a direct implication of the closed universe's spherical geometry, as it bends the fabric of space-time itself. The implications are astounding. Could we one day see the back of our own heads by looking far enough into the cosmos? Imagine living in a massive cosmic sphere, where the light from a distant star could eventually reach us from the opposite direction. Now let's consider the open universe theory. This intriguing concept suggests a universe in perpetual expansion, never slowing, never resting. Picture an infinite cosmic race, galaxies as runners constantly accelerating, creating more and more distance between each other. The shape of such a universe is often likened to a saddle, a hyperbolic plane bending away from itself at every point. This curvature creates a universe that not only expands but does so at an increasing rate. The open universe theory is one of many attempts to understand the vast, enigmatic cosmos we inhabit. It's a theory that embraces infinity, a concept as mind-boggling as the universe itself. So what does this mean for us, for our future? Well, in an open universe, there would be no big crunch, no fiery end, just a ceaseless journey into the ever-widening cosmic yonder. In an open universe, we would see endless expansion, with galaxies moving apart faster and faster. Ever heard of the multiverse theory? It's a concept that seems to have been ripped straight from the pages of a science fiction novel, yet it's a serious proposition within the scientific community. The theory suggests that our universe, the one we interact with and observe daily, might not be the only game in town. Imagine an infinite number of universes, each existing concurrently yet independently. This collection of universes is what we call the multiverse. In this grand cosmic ensemble, each universe could be governed by its own set of physical laws. Some might be similar to ours, while others could be radically different. Picture universes with more than 3 spatial dimensions, or where time runs backwards. The possibilities are as vast as the multiverse itself. The multiverse theory presents a humbling perspective. We might not be the center of it all. In fact, we might be just a tiny speck in an infinite cosmic ocean of multiple universes. Now let's delve into the intriguing holographic universe theory. This theory takes us on a quantum leap, proposing that our seemingly 3-dimensional universe might be a projection of 2-dimensional information at the cosmic horizon. Imagine a hologram. You can move around it, view it from different angles, and it appears 3-dimensional. But in reality, it's a 2-dimensional image that contains all the information needed to create the illusion of 3 dimensions. This fascinating concept is at the heart of the holographic universe theory. But why propose such a mind-bending scenario? Well, it could potentially reconcile 2 of the most successful yet incompatible theories in physics: quantum mechanics and general relativity. On one hand, quantum mechanics describes the world of the very small, where particles can exist in multiple states simultaneously. On the other hand, general relativity describes the world of the very large, where massive objects warp the fabric of space and time. These theories clash when we try to describe what happens inside black holes or during the Big Bang. But if the universe is a hologram, this clash could be resolved. The holographic principle suggests that all the information in our 3-dimensional reality can be encoded on a distant 2-dimensional surface. In a holographic universe, what we perceive as 3 dimensions could be just an illusion. It's a concept that challenges our understanding of reality. And although it's still a theory, it's a fascinating glimpse into the potential nature of our universe. Next on our list is the fractal universe theory. A concept that might be familiar to those who've marveled at the repeating patterns in a snowflake or the branches of a tree. The fractal universe theory suggests that the universe's structure repeats itself at every scale, from the smallest to the largest. Just as a fractal is a geometric figure, each part of which has the same statistical character as the whole, this theory proposes that each part of the universe, no matter how minuscule or massive, mirrors the whole. It's a mind-bending concept that pushes us to think beyond the conventional boundaries of space and time. This theory challenges the cosmological principle of uniformity. This principle, a cornerstone of modern cosmology, assumes that the universe, when viewed at a sufficiently large scale, looks the same no matter where we are or in what direction we look. But the fractal universe theory turns this on its head, suggesting a universe that's anything but uniform. A universe that's infinitely complex and endlessly repeating. Consider for a moment the vast cosmic web of galaxies. According to the fractal universe theory, this intricate network is but a small piece of an even larger cosmic pattern, which in turn is part of an even bigger pattern, and so on, infinitely. In a fractal universe, galaxies might be just tiny parts of colossal cosmic patterns. It's a perspective that invites us to see the universe not just as a collection of individual parts, but as a complex, interconnected whole. Let's ponder the bubble universe theory. Imagine a cosmic foam populated by an infinite number of bubbles. Each bubble, including our own universe, is unique and separate, floating in the froth of this cosmic sea. This theory is closely entwined with the concept of eternal inflation, a theory that suggests the universe is constantly and eternally expanding at different rates in different places. In this endless sea of cosmic bubbles, new universes are being created all the time, each one with its own laws of physics and unique properties. Our universe could be just one of these countless bubbles, a tiny speck in an ever-expanding cosmic foam. The idea that we could be living inside a cosmic bubble challenges our understanding of the universe and our place in it. This theory pushes the boundaries of our imagination and opens up a world of infinite possibilities. If the bubble universe theory holds, we could be living inside a cosmic bubble. Ever thought of a universe shaped like Swiss cheese? Well, that's exactly what the Swiss cheese universe theory proposes. This theory takes a fascinating approach by suggesting that our universe is full of holes or voids, much like the holes we see in a block of Swiss cheese. But what's interesting about these voids isn't just their existence, it's what they could mean for the overall structure of the universe. These voids may account for the large-scale structure of the universe that we observe. The Swiss cheese universe theory suggests that these voids are not just empty spaces, they're integral components of the universe's structure. They could shape the universe in ways we're only beginning to understand, influencing everything from the distribution of galaxies to the patterns of cosmic radiation. So while they may appear to be empty, these vast voids could be as important as galaxies and clusters. In a Swiss cheese universe, vast voids could be as important as galaxies and clusters. Lastly, let's examine the digital universe theory. This fascinating concept proposes a possibility that might seem straight out of a science fiction novel. It suggests that our universe might be nothing more than a gargantuan simulation or a computational system on an incomprehensible scale. Imagine this. Every particle, every galaxy, every star, and each of us could be part of a complex program. A digital code being processed and run by an enormous cosmic computer. Even the laws of physics that govern our reality could be just algorithms in this supercomputer. This theory, though speculative, raises profound philosophical questions about the nature of reality and existence. Are we living in a real universe or just experiencing a digital reality? While it's a mind-bending concept to wrap our heads around, it's important to remember that, as of now, this remains a theory. In a digital universe, we could be just information being processed in a colossal cosmic computer. So there you have it. 10 fascinating theories about the shape of the universe. Each one of these theories presents a unique perspective on the cosmos, challenging our understanding of reality and pushing the boundaries of our imagination. First, we explored the flat universe theory, a concept suggesting that the universe extends infinitely in all directions, creating a flat, boundless expanse. Then, we delved into the closed universe theory, which posits a finite universe curving back onto itself in a four-dimensional sphere. In contrast, the open universe theory envisions a universe that curves outward in all directions, creating a saddle-shaped cosmos that expands into infinity. On the other hand, the multiverse theory takes a leap into the realm of the extraordinary, proposing that our universe is just one of many in an endless cosmic ensemble. The holographic universe theory brought us a radically different perspective, hypothesizing that our three-dimensional reality is a projection from information encoded on a two-dimensional surface at the universe's boundaries. Meanwhile, the fractal universe theory suggested a universe composed of self-replicating patterns on increasingly larger scales. The bubble universe theory added another layer of complexity, proposing that our universe is just one of countless bubbles floating in a higher dimensional space. In contrast, the Swiss cheese universe theory suggested a cosmos filled with voids, resembling a block of Swiss cheese. Finally, the digital universe theory brought us to the edge of the conceivable, proposing that the universe is a vast, complex computation. Each of these theories paints a distinctive picture of the universe, offering different answers to the age-old questions about the nature of reality and the ultimate fate of the cosmos. They remind us that the universe is a complex, mysterious entity, filled with endless possibilities and infinite wonder. Whether flat, closed, open, or something else entirely, the universe continues to be a source of endless fascination and mystery. Until we unravel these mysteries, keep gazing at the stars and wondering, but the universe isn't the only place where endless possibilities exist. Right here on this platform, you too can be a part of the cosmic conversation. If you've learned something new from this video, or even if you're left with more questions than answers, we'd love to hear from you. Give this video a like if it's expanded your horizons or challenged your beliefs. Share your thoughts, opinions, and theories in the comments section. Who knows, You might inspire someone else to look at the universe in a different light. Don't forget to subscribe and press the bell icon so you can continue this journey of cosmic exploration with us. And remember, the universe isn't just out there in the cosmos. It's right here in the shared knowledge and curiosity of our community. So share this video with your friends and family. Let's make this universe of knowledge bigger and brighter together. Until next time, keep gazing at the stars and wondering. The universe is waiting for your discovery.